All right, welcome everybody. So today we're going to be doing chapter 8 of Cisco Network Academy, Connecting Networks course. And today we're going to be discussing about network troubleshooting. Now, these are the things we're going to discuss about network troubleshooting. We're going to talk about the different troubleshooting methodologies. We're going to talk about the troubleshooting scenarios. And that's pretty much all. So let's get started with the first topic, which is troubleshooting methodology and how does it actually work. Now, one interesting thing is the reason why we have troubleshooting in the end, in the very last chapter of everything that you guys learn about network infrastructure, about Cisco stuff. Why is troubleshooting the very final step? Why is troubleshooting the very final thing you need to learn? That is because whenever you're trying to troubleshoot networks, you have to understand the networks, you have to understand the technologies very well before you start troubleshooting. If you don't understand routing protocols, you won't be able to troubleshoot routing protocols. You won't be able to troubleshoot why you are not able to ping from one computer to another computer in a remote location. So the first step in order to begin with the troubleshooting is to remember how the technologies work, to remember the OSI model, to remember how the bits and bytes, the communication happens between one computer to another machine. Now, the first step when troubleshooting networks, how are you going to troubleshoot something you don't understand entirely? So one step for us to understand the network is to try to find out the network documentation. Now, if you study network design with me during your Cert 4, you know the importance of having your network topology documented. And why do you document the network? Because it's going to be better for you to understand the network. It's going to be better for you to understand the connections. It's going to be better for you to understand the logical connections and so on. Now, you remember that from your Cert 4, from your introduction to networks, that when we talk about computer networks, it's not only a matter of being physically connected, it's a matter of being logically connected as well. So when we talk about being physically connected, that would be having a wire, an Ethernet cable connecting one computer to a switch, but that doesn't mean you will be able to communicate. For you to communicate, you have to make sure the logical connections, they have been established. You have to make sure your computer will have a valid IP address, which belongs to the same local area network address that the computer is connected to. How do you make sure this is correct in your network? If you have the proper documentation. If you have the proper documentation, it's going to help you out when you try to find out if the problem is the default gateway address. You will be able to tell if the default gateway is in the same network as the computer. Because remember, the default gateway has to be an address in the same local area network as the computer that you were connecting to the network. Now, for troubleshooting purposes, we have to completely and accurately describe what we have configured. If we have the network documentation, and we make sure the network documentation makes sense, we can then proceed to find out if the devices have been configured correctly according to the network documentation. Sometimes we have a network documentation which seems to be correct. The default gateway is fine. The IP address of the machines are all correct. But when we actually start investigating the devices, the computers, the routers, the switches, when we check the configuration, one of the IP addresses have been mistyped. So someone has actually entered the wrong address. If we don't have the network documentation, it's much harder for us to find out that information. Once again, when you guys did network design, we discussed that sometimes the network documentation is not available to us. There is no network documentation, or the network documentation is not enough. When this is the case, we actually need to do something called a network audit. With the network audit, we're able to just basically have the big picture of how the network looks like, of all the IP addresses that have been configured, all the device models, and so on. Now, when documenting the network, when we actually need to perform a network audit, we have to be able to find out the device name. We need to be able to find out the operating system and version, because some of the Cisco IOSs, they have different capabilities. We have to be able to find out the IP address information. We have to be able to find out the subnet mask and the prefix length, because this is what basically is going to dictate if computers are in the same logical network, if they are not, if we need to troubleshoot the default gateway or not, and so on. When performing the network audit as well, we need to be able to find out the default gateway information and the DNS information on all the machines. If there's any high bandwidth network application as well, we also need to be able to find out that information. This is all obtained when we are doing the audit if the network documentation doesn't exist. Network topology diagrams. So we discussed about the topologies when we studied network design. We have two main types of topologies, the physical topology and the logical topology. The physical topology will just basically represent the physical connections, the physical locations of all the devices, and it's usually going to have the device names, the identification, the exact location if the device is located on a rack. It's going to tell us the rack shelf and so on and so forth. So the physical network topology is one of the easiest ways we can find out the exact location where the device is physically. We also have the logical topology, which is similar to the physical topology, but doesn't usually include physical locations. The logical topology includes information which is useful in regards to the logical networks. So in the logical topologies, where we're going to see the network addresses, the IP addresses, the IPv6, IPv4 network information, and so on. Some logical topologies, they even omit, they hide the switches, because the switches, they don't usually have any logical addresses, especially if they don't have a switch virtual interface for management. Some of the logical topologies, they even hide the switches. Now, the physical topology, just as I already mentioned, will include the device type, the model, manufacturer, operating system version, the iOS version, the cable type. So if it's an Ethernet cable, if it's a fiber optic cable, we're going to have this information highlighted in the physical topology as well. If there's a serial connection between the routers, it's also going to be highlighted as well. The cable specification, especially if we have different types of cables in our network, such as Cat5, Cat5e, Cat6 types of cables, they will all be identified in the physical network topology. We're also going to have connector types sometimes, and also cabling endpoints. So where the cable terminates. So that's why with the cable endpoints, that's why we usually have the port numbers as well in the physical topology. In this one here, we don't necessarily have it, but sometimes it's hugely beneficial if we also include the port where the connector terminates. Now, how about the logical topology? As already mentioned, the logical topology will usually include the information about the IP addressing, which is the most important information and which is the thing that will actually tell you if the topology is a logical or a physical. In the physical topology, the IP addressing doesn't matter because the IP addressing is just the logical information about the devices. Some logical topologies, they will include the port because the IP address has to be associated to a certain port for some devices. And that's why sometimes we also include the port number in the logical topology as well. Now, most of the time, which I actually see in real life, is that the port number is usually on both of them. All right. So usually the port numbers is on both of them in real life scenarios. Now, in the logical topology, we're also going to have information about the device identifiers, the services that are running on certain devices, the name of the devices. Now, if the devices, they belong to a certain VLAN, it's also going to tell us as well. It's going to tell us the connection type as well, the frame relay, DLCY for virtual circuits, if they exist. Now, if we have a VPN as well, we're also going to have the tunnel information. For example, the GRE IP address for the endpoints will also be shown in the logical topology as well. We're also going to have WAN technologies that have been used and also data link protocols. In other words, if we have VLANs, if we have encapsulation types and so on, this will be in the logical topology as well. Now, when we're doing the network troubleshooting, the first step that we need to do is we need to ask ourselves if there has ever been a network baseline. Now, the purpose of having a network baseline is actually to find out if there's actually an issue with the network. Now, people may be complaining that the network is too slow, but there might be that the network has always been that fast, all right? So it might be that it's just outdated already and the entire network has to be replaced, or some devices or even connections, they have to be entirely replaced. Now, when we have a network baseline, we actually have a starting point for the troubleshooting. We actually have a reference to find out if there's an issue, to actually try to find out what the issue is. Now, the network performance baseline is used to establish what is considered to be normal behavior. If we don't have a baseline, we don't know what the normal behavior of a network should be. And if we don't know what the normal behavior should be, it's going to be really hard for us to troubleshoot the network. We're not actually going to know what the problem is. We not even know if there is a problem in the first place to troubleshoot. The performance baseline requires collecting evidence, collecting performance. Now, the network baseline, which is just basically establishing the normal behavior of the network, is usually done when the network is implemented. So usually what happens is the network is implemented, the normal activity is established, so we have the normal amount of employees connected to the network, and then we can basically determine, we can basically determine what is the normal level of operation for the network. That would be called the network baseline. Now, usually what's good to establish the network baseline is to find information about the bandwidth, the speed, to find out information about the latency, to find out information about the connection of the devices, if the connection is always up, and so on and so forth. Now, how do we actually establish the network baseline? We have actually a guide that tells us that after the implementation of the network, after the network is fully operational, we can start to establish what the normal operation is. In other words, we can establish the network baseline. The first step to establish the network baseline is to determine what types of data to collect. So the first thing is we need to determine what is actually most important for us in the network. So we start out with a few variables that represent the defined policy, and then we can then capture what is important for us. Is it important for us to find out what the speed is, the speed of the link is, the bandwidth, the latency? What are we actually interested in capturing? The second step is to identify the devices and ports that we are interested in. So we basically find out where the traffic is going through the network to reach the destination. And then we can just establish that that port has to be up in order to have a certain baseline. It has to have a certain IP address configured, and so on and so forth. We can also determine the users that are connected to certain ports, especially if we have VLANs in the network. We can find out if it's operating at a normal behavior. Our third step to determine the baseline is to determine of how long we're going to be collecting information, which is just basically the baseline duration. Now, when we usually have a duration of time which is too short, we don't have a very good picture of the network. We actually need to collect information for a reasonable amount of time. Now, collecting network information for a few seconds is not enough because throughout the day, the network behavior changes very drastically, especially if we have a business where the operation spikes at a certain time in the morning. We actually have to be able to collect the information for, let's say, a whole day or maybe a whole week and so on. After that, we can capture and we can analyze the trends. We can take screenshots of the CPU utilization because we know that there's a CPU utilization on all networking devices. And when there is more traffic flowing through the network, that's where the devices will have to be working more. Now, when we establish this baseline, we can then actually keep track of the network evolution. We can keep track if the network is outdated, because once the devices they are reaching a too high CPU utilization, they're just basically being overloaded with the amount of traffic, and then we basically need to start thinking about updating the network. Now, measuring data. How do we measure data in our Cisco iOS? There are multiple commands that will help us collect information for our baseline and for our network audit. Now, these commands, they're pretty common commands. The first one of them will allow us to check the version of the iOS, the operating system that is currently running. The second, which is the show IP interface, that could be for IPv4 or IPv6. The only difference is the v6 in the command. Will allow us to collect information about the logical addressing scheme that has been configured in the devices themselves. We also have the show interfaces to actually grab more details about the interface itself. Now, the difference with the show IP interface and the show interface is that the show IP interface shows us more logical information. So with the show IP interface, the logical information is more important to us, and that's why we're going to be able to see all the IP addressing that has been configured on the interfaces and so on. With the show interfaces itself, we are more interested in the physical interface information. For example, the bandwidth of the link, if it's a half duplex, if it's a full duplex connection, and so on and so forth. We also have the show IP route, show IPv6 route. Now, these commands, they shows us what the router knows. Please remember that the show IP route will show all the networks that the router knows about. When we're troubleshooting, if the network is not in the routing table and if there is no way out, the router will just not be able to reach the destination and will just drop the packet. So that will basically means your ping will not be successful. So one of the first steps when I'm troubleshooting a ping to a device in a different network in a remote location is for me to find out if my router, my first router, knows how to get there or knows how to forward this packet. Now, for me, the show IP route is one of the most important commands ever when you're troubleshooting connectivity between one computer to another computer, which is not in the same local area network. We also have the show ARP. Now, show ARP and show IPv6 neighbors, they will allow us to troubleshoot the ARP process. Does anyone remember what the ARP does for us? And it's a shame if you don't remember because you are already in the diploma and you should know what ARP is.
It's a resolution protocol.
So it's the address resolution protocol, but what does it do? What does the address resolution protocol do?
I can't remember. It isn't like a communication protocol, something like that.
It tries to recognize addresses.
Guys, remember, when when we,
Right?
yeah, go ahead, Max.
I think it is something to do with duplicate address or something. So it tries like to have each machines be have a unique address. So like if there is an duplicate address for solution, it tries solving it.
That was a good guess, Max, but no.
Is it actually? I think it's like a map doing mapping, some kind of like on link layer address. Something like
Guys, remember one thing.
It is used for identify the MAC address when we don't know it. We have the IP, but we don't know the MAC address.
Oh yeah.
Exactly. So, guys, the easiest way you can remember ARP is to remember a ping. All right. When we actually have to communicate, we need to have both the IP and the MAC. So when we are trying to ping another device, remember the OSI model, we need to have a MAC and we need to have an IP. Now, when we ping another computer, for example, or when we do a trace route, or when we do whatever, and we know the IP address, the computer needs to have a way to find out the MAC address for us. All right? And the way that it does this is through ARP. So ARP is just basically going to be a message that the computer will send out to everybody in the same network. So it's going to be a broadcast message to everybody else. And it's going to ask if there's anyone with a specific MAC address related to an IP. Okay? So I'm just going to ask, hey, is there anyone here with this IP address? Can you please tell me your MAC address? And that's what ARP resolution will do for us. Now, when we show ARP, we want to find out if our computer has been able to find out the MAC address information. If the computer is not able to find out the MAC address information, the computer will not be able to communicate with another computer. Now, when we want to communicate with another computer outside the local area network, the ARP will actually gives us the IP address of the gateway, the MAC address of the gateway. All right. So you guys remember? So when I'm sending information outside of my network, I need to go to the gateway. All right. So the MAC address resolution will be the gateway if I want to try to reach out to another computer outside the network. Now in IPv6, we don't have ARP. ARP doesn't exist in IPv6. In IPv6, we have, does anyone know? The name of the protocol in IPv6, it's not ARP.
Is it IPv6?
That was a good guess, Max, but no.
Isn't NDP neighbor discovery protocol?
Yes, good, Peter. So it's the neighbor discovery protocol, NDP. It will allow us to do the same. Now in IPv6, we have NDP because we are going to ask the neighbors, all right, with IPv6. So it's going to be a message that we're going to send to the neighbors. The name of this message is neighbor discovery, right? And then we're going to receive a message back from the neighbor that has that specific IP address. And then we will have the IPv6 to MAC address mapping, all right? Now, another command, so the ARP, the show ARP and show IPv6 neighbors is a very good troubleshooting step as well, because if we don't have an entry in the ARP table or the neighbor table for a certain IP address, even if it's remote connections or whatever, if we don't have an entry in our table, we just basically don't know how to send the frame to the destination. We also have the show running config, which will allows us to troubleshoot all the commands that we entered in our networking device. So the show running is very useful when we're trying to troubleshoot VLANs, for example. Whenever we do a show running config, we're going to be able to see if in the router we have the correct sub interfaces, if the sub interfaces are associated to the specific VLAN. It also allows us to see if we have changed the native VLAN, if we have a trunk port in a switch, for example, and so on. We also have the show port to verify the status of ports on a switch. We also have the show VLAN and show VLAN brief, which will allows us to troubleshoot the VLANs. And we also have the show tech support, which is useful for collecting a large amount of information about a device specifically for troubleshooting purposes. We also have the show IP cache flow to display a summary of the net flow accounting statistics. Now, net flow is a technology that allows us to keep track of specific types of traffic. So, for example, we are able to see the amount of packets that are going from one source to another specific destination, and so on. Now, there's one troubleshooting challenge activity for you guys to complete. So you just basically want to have to use these troubleshooting commands to verify the information on multiple devices and to just basically try to find out what the issue is. Now, general troubleshooting procedures. Now, we have a troubleshooting systematic approach that we should be following. The first stage is to gather the symptoms. So how are you going to troubleshoot if you don't even know what the problem is? All right. Now, I think this is like in the medical field, it's a very similar way when they try to find out what kind of disease that you have. The first step that they take is to gather the symptoms. All right. So what is the major symptoms that are displayed? Is it because out of nowhere, you just cannot reach the destination anymore? What are actually the symptoms? Is it the problem is that you are not able to access a web page? Is it because of DNS? What the issue is? So once you know exactly what the problem is, you can isolate. Now, when you actually gather the symptoms, you find out many issues. Now, once you narrow down the problems, you can isolate to a specific problem. So you're not able to do a DNS lookup, for example. That could be many things. It could be the DNS server information. It could be that the connectivity is lost to the DNS server. It could be that you have no connectivity to the destination whatsoever. So you can gather all the symptoms. Now, when you isolate the problem, you have a better idea of what the issue actually is. So, for example, if you think the problem is the DNS, check the DNS, okay? Try to isolate the problem. Okay, so I can resolve the name, but it's not actually giving me the correct information. I cannot resolve the name, but I can ping the server. I can resolve the name, but I cannot ping the destination of the DNS resolution. So you can then keep narrowing down and isolating the problem. Once you isolate the problem, you can implement the corrective actions. So you can then proceed to trying to fix the issue. And then if the issue has been fixed, you can document the solution and you can save the changes. Now, documenting the solution is a key step because if it happens again, you know exactly what to do. If it didn't fix the problem, you can just come back to the first step. Hopefully you have done things that when you try to troubleshoot it again, and when you start doing the steps all over again, you have less chances of failing because you have done something already that might have fixed something else. All right. Now, sometimes when we're troubleshooting things, we actually need to repeat this process over and over again. All right. Until we completely fix all the issues. And that is because sometimes in computer networks, one thing that breaks start breaking multiple other things, and we just basically have to fix one by one until we reach the full functionality of the network again. All right. Now, 5 steps for gathering the information. So how do you gather the information? You determine who owns the problem. Okay. You narrow the scope and you gather the symptoms. And after that, you document the symptoms. Now, gathering information is just basically asking people what the problem is basically checking the systems for functionality and so on. After that, we can determine the ownership. Now, determining the ownership is extremely important because sometimes we actually spend multiple hours troubleshooting a network just to find out that the problem is with the ISP and there is nothing we can do except contacting the ISP. So we have to determine the ownership of the problem. Is the problem actually the internal side of the network, or is it the external side of the network? Is the problem your problem, or is the problem the ISP's problem or someone else's problem? You have to find that information out. After that, we can narrow the scope. After you determine the ownership, we can then proceed to narrow the scope, which is basically determine if the problem is at the core, distribution, or access layer. Now, please remember that most of the networks we have, they follow the hierarchical structure. In other words, we have the access layer with all the access switches. We have the distribution layer with all the layer 3 switches and connecting all the access layer switches. And we also have the core layer. When we narrow down, we can find out where the issue is. Is it at the access? Is it at the distribution? Is it at the core? Is it not even my problem? Is it the ISP side? We can find that information out. After that, we gather the symptoms from suspect devices. So we go to every device and we use our troubleshooting commands to find out what the problem actually is. And after that, we can document the symptoms, we can write them down, or we can save into a TXT file and so on and so forth. This will be extremely important. It will help us in the investigation stage after we collect and gather all the information. Now, how do we actually collect information from the users? The easiest way to do that is asking questions, all right? So I'm really sorry, you have to have some people skills to be in IT, especially if you're going to work with help desk. You have to be patient with people. You have to ask them questions. And whenever you think you have asked enough questions, you have to go deeper and ask more and more questions. But you actually have to be subtle when you're asking a question. Do not make any questions that will sound that the person that you're asking is stupid or they don't know what the technology is. You actually have to ask general questions. You have to keep in mind that the person that you're asking the questions, they're usually not technical as you, so they will not understand technical terms. Now, for you, a ping sounds very familiar. A trace route sounds very, very familiar. But now, if you're trying to explain what a ping, what a trace route is to your mom, for example, it's going to be a very hard task. All right. So you have to keep this in mind. The people that you usually going to ask the questions, they are people that have no idea what IT is. They have no idea what a ping is, what a trace route is. So you have to ask questions which are more practical questions about the technologies and about the things that they actually need. All right, instead of the actual network. Now, using the layered model for troubleshooting, when we're troubleshooting after we gather the symptoms, when we're narrowing the scope, we have to understand the technologies. We don't understand the technologies, we won't be able to troubleshoot, guys. All right, so that's why the OSI model, which just basically tells us how communication works, is so important. And that's why you learn the OSI model so many times in your Cert 4, on your diploma, everywhere, okay? Everything relates to the OSI model. You don't understand how the OSI model works, you don't understand how to troubleshoot a network. You're going to be completely lost when you try to troubleshoot. Now, the OSI model will describe us the rules of communication, the step-by-step that needs to be taken when one device called the end device wants to communicate with another end device, which is also connected to the network. So the OSI model dictates us the steps that the data, the information, will be broken down into smaller and smaller pieces, will be identified, and will be sent out throughout the internet until it reaches the destination. So if there is one important thing that you must know as a network engineer, is the OSI model. If you go to the industry and you start working and you don't know, you don't master the OSI model, it's going to be a shame on you. People will not going to respect you, all right, as a professional. So if you really want to call yourself a network engineer professional, you have to understand the OSI model. Now, a quick review about the OSI model. We have the top layers, layers 7, 6, 4. We have the bottom layers 4, 3, 2, 1. The bottom layers, they are more associated with the intermediary devices. Remember the intermediary devices that you learned in your networking essentials? Back on your Cert 3, you have the intermediary devices, which are all the devices between the endpoints. They are not the final source. They are not the final destination of the information. They are just basically in the way. They are on the way from the source to the destination. The end devices, they are the very final source and the very final destination of the information, of your actual data. And that is why they are called end devices, end systems. End points is just the same, all right? Now, when troubleshooting using the OSI model, we also need to know the similar model which describes the communication process as well, which is the TCP/IP model. So you guys have to remember that the TCP/IP model is very similar to the OSI model. The TCP/IP model is a little bit more specific. And why is it more specific? Because it will actually say that in the transport layer, we are going to be using TCP technologies. In the network layer, we are going to be using IP as the protocol of choice. And that's why the TCP/IP model is said to be the basic model for the internet, because the internet nowadays relies on TCP and IP as the transport and network models, network protocols. All right. So there is actually a way that we associate the TCP/IP and the OSI model. And how are they associated? First, the OSI model has 3 layers at the top. When we are talking about the TCP/IP model, we can basically combine all of these into one single layer, which is application. So everything that we see at the top of the OSI model, the application, the presentation session, they will be combined into one single layer in the TCP/IP model, which is called application. The transport layer is exactly the same as it is, except that it has been specified as TCP or UDP as the protocols, and the network layer is going to be translated into the internet layer. All right. And the 2 bottom layers, the data link and the physical layer, they are combined into one in the TCP/IP model, and they are called network access. And it makes sense because that's the first starting point to have access to a certain network, is to have a physical connection and a data link connection. If we want to have full connectivity, we have to go up and have an IP network, have an IP address, and then everything is going to be fine. Now, when we are troubleshooting, there are many ways we can start troubleshooting the networks. We have the bottom up and the top down approach. The bottom up method is starts troubleshooting everything in the application level. So you start to find out what is the problem in the applications themselves, and then you move all your way down. Now, in the bottom up, you do the opposite. In the bottom up, you start troubleshooting the physical connections first. Now, whenever I'm troubleshooting an issue, I really like to do the bottom up because I don't like to spend my time trying to troubleshoot applications, trying to troubleshoot routers, trying to troubleshoot switches, just in the end to be able to find out that there was a problem with a certain cable. All right. So particularly, I like to start checking all the physical connections first, making sure all the physical cables are fine and correctly attached to the appropriate port, and then I start moving up in the OSI model to troubleshoot all the other layers. Once you find out that the cables are attached properly, they are connected to the appropriate port, they are cables that actually work. And how can you test the cables? With a cable tester. So you go there, you use a cable tester to check if the cable is fine. And then once you make sure all the connections are working fine, we can then proceed to the other layers going up in the OSI model or the TCP/IP model. All right, we also have the top-down. The top-down approach starts at the top layers, so that basically means we start troubleshooting the application layer first. Now, when is this useful? This top-down approach is extremely useful when we don't immediately have access to the physical premises. So if you are an engineer, for example, and you don't have access to the physical connections in the beginning, you are working from home, for example, when you still have to be able to troubleshoot stuff, it is better for you to start at the top. So you go to the user machine and you start executing the tests. So you try to access a web page, you try to ping another device, you try to do an NS lookup, you try to execute the commands at the application level first. And then you move down in the OSI model, you check the router, you check the routing table, and so on and so forth. You check the ARP table to make sure you have a mapping between the IP address you want to reach and the MAC address, and so on and so forth. All right. And then if none of these have worked, you most likely know that the problem is the physical layer, and then you can request access to the physical premises, to the physical connections, to test the cables and so on. For the more experienced network engineers, for the senior network engineers, after you've been working with this all your life, over 10 years, you will know that some problems, they are specific to some layers. So if you're a more experienced engineer, you've been doing this for a long time, you know exactly what happens when a certain issue occurs in some of the layers. You can go to the layer exactly. That's called the divide and conquer troubleshooting method. If you have a better idea where the problem is, in which specific layer of the OSI model, you can just jump straight into that layer and start troubleshooting that layer specifically. All the troubleshooting methods. Now, in addition to the systematic approach that we just discussed, there are also less structured approaches. We have the educated guesses. So if you have a better guess of what the issue is, you can just then go to the issue straight away and find the problem. Guidelines for selecting a troubleshooting method. Now, whenever we have access to the software and we don't have access to the physical location in the beginning of the troubleshooting, I recommend you to go with the top-down approach. Now, if you have access to the physical location, you have access to the physical equipment and the physical connections, I suggest you to go with the bottom up. All right. If you have an idea that there's a problem with the hardware, if you have an idea that there's one of the devices with an issue, you can actually check the LED status on all the devices, and you suspect that there is an issue with the device itself, go with the bottom up approach. It's going to be the better approach. Now, if you apply and you have previous experience, it's just like I said before, you can use the divide and conquer method so you can have a better idea what layers will have the problem, or you can also try to do the bottom up approach if you have experience, but it's an entirely completely new problem for you. All right, let's go to our troubleshooting scenarios now, which is the second part of the lecture. Now, we have IP SLA. What is IP SLA? Now, IP SLA is a very interesting thing because IP SLA is a technology that allows us to have some pre-configured tests so that we don't need to be executing the tests all the time. We can actually pre-configure the tests. So we can schedule the tests to be happening once in a while without actually having to execute the tests. IPSLA is a very cool technology. It allows us to be monitoring and measuring and verifying networks without actually having to type the commands all the time. All right. Now, it's useful for us to keep track of the networks, to keep track of the network health, to keep track of the network connections without actually having to type the commands all the time to be checking connectivity. This is one example of IPSLA. Now, instead of using a ping command manually all the time to check connectivity, we can schedule pings to happen once in a while with IPSLA. Now, this show IPSLA application is showing us the tests that IPSLA have been executing. In this specific one, we have an ICMP echo, which has been scheduled to be happening once in a while without actually requiring us to go there and doing it manually. Now, how do we configure IPSLA? For the echo, we can specify with the command ICMP echo, and then we specify the source and the destination. And after that, we can create the schedule. The schedule will basically be when the tests are going to be executed and how often they will be executed. All right. How do we configure that? With the IPSLA schedule, and then we can specify the options. When do we want to start? Until when? So what is the stop date, the stop hour, the stop minute, whatever. All right. This is an example of an IPSLA configuration. We have an IPSLA 1, which is just basically specifying what are the tests that will be executed in the instance 1 of the IPSLA. In this case, we have an ICMP echo, which is just basically a test that router 1 will try to ping router 3's interface, all right, once in a while. The frequency study, so every 30 seconds interval, router 1 will automatically execute a ping test to the interface of router 3, which is connected to router 2. Now, once we create the test itself, remember that we have to create the schedule. So we basically have to specify the start time and how long it will last. In this example, we have the IPSLA schedule for the first instance of the IPSLA. It's going to start right now and it's going to last forever. So unless I disable it manually, it will be running forever. All right. So it will always be testing connectivity to router 3 no matter what happens. And it will begin doing this right now. Once we configure IPSLA, we can verify the configuration with the command show IPSLA config and also the show IPSLA statistics. With the show IPSLA config, we're going to be able to see everything that we configured, the type of tests that are being executed, the destination of the test, and so on. And also the schedule as well. We also have the show IPSLA statistics, which is just basically going to show us the statistics of the tests. If they have been successful, if there has been any failures, and so on and so forth. There is one lab for us to configure IPSLA using an ICMP echo request. So please make sure you guys do that to understand a little bit better how IPSLA works. Now, we have other multiple software troubleshooting tools. We have those called network management systems. Now, network management system tools, they include device level information, configuration, and fault management tools. Now, these tools, they're amazing tools because they will display networking information in a way which is easy to digest. So it will show the nice graphs, it will show the nice statistics, it will show the nice percentages, and so on and so forth. Now, these network management tools, they are amazing tools for us, specifically when we are designing the baseline, when we are determining the baseline for a certain network, these network management system tools, they will allow us to see the behavior of the network in a way that is so easy to understand based on the amount of traffic for specific IP addresses, for specific protocols, and so on and so forth. We also have the protocol analyzers. Now, the protocol analyzers that you guys should be pretty familiar at this time is Wireshark. Wireshark will allow us to see the packets, will allow us to dissect the frames and packets, will allow us to check the source and destination IP and MAC address, will allow us to check the transport layer information as well, and so on. We also have the hardware troubleshooting tools, which will allow us to troubleshoot the physical connections. We do have cable testers, which are one of the best friends of any network administrators or network engineers. Because like I said, some people, they prefer to start troubleshooting the bottom layers. So if you like to start troubleshooting the physical layer, the cable tester is going to be your best friend. Nowadays, we can actually buy cable testers super cheap on the internet. They test every single one of the wires in a cable. So they will basically determine if there's a faulty cable. Some of the most expensive cable testers, they will actually test way more things in a cable as well instead of just the wires. They can test the bandwidth, they can test the duplex mode, or pretty much anything in a cable without actually connecting both ends to the cable tester.
Where I can get this one covered?
On some sites on the internet, but the thing is, these ones are too expensive, Imran.
Oh yeah, these are like a couple of $1,000s. I played with them, and it's such a nice toy. Such a nice toy.
Yes, it's amazing. They've got like colors, they've got diagrams. It's really good. Now the thing is, they're really expensive, so it's going to be very hard to see these with a person. They're usually owned by the company. So some of the companies, they will buy some of these and they will leave some of these with the engineers, but they will not going to give them for free, because they are very expensive. All right. Some of them, they can actually detect the device that they're connected to. If it's a router, if it's a switch, stuff like that. Yeah.
And it's also great. It can actually show you, like if you have a 100-meter cable, it can show you exactly what is the problem, like with the wire, like 5 or 10 meters. Or...
Yes, they can measure. They can measure exactly where the fault is. Yeah, pretty amazing technology. All right. Now, another step that we need to take when we're troubleshooting networks is using the syslog. Now, syslog is one of our best friends as well when we're troubleshooting networks, because you guys know that when there is an issue with the device can be configured to generate a message. All right. So it's just basically the device becoming a little bit smarter and basically generating a message to let the engineers and the administrators know that there is possibly an issue. All right. Now, we have many levels of severity, which is just basically associated with the syslog message. The levels are 0 all the way to 7. 0 is the highest level. 0 represents an emergency. So an emergency is when the system is unstable. An emergency is usually generated when there is a problem with the device itself. The CPU is overloaded or the device has been restarted because it was overheating. Like, it's something that is an emergency. It has to be remediated as soon as possible. We also have alerts, which are immediate actions that are needed. We have critical conditions. We have errors. We have warnings, notifications, information, and debugging. So these are the levels of severity that we have on the syslog messages. Now, when we're configuring a device to generate the syslog messages, we can specify which type of messages the device should generate. when we specify the level that the device should generate, the device will generate everything below the level that we specify. So if we specify the device needs to generate syslog messages level 3, what we're basically telling is that device should generate messages all the way to 3. Okay, so this is how it works. So if we specify that the device should generate messages all the way to the debug level, the device will generate all the levels all the way up to 7. All right. Now, if you guys have plans for doing the CCNA exam, you have to remember all the levels of debugging, all the way until debugging. So you have to remember the keywords, what each one of the levels is associated to in regards to the emergency. So what is level 3? Error. What is level 4? Warning. So you have to remember this. All right, physical layer troubleshooting. Now, just like I said, physical layer troubleshooting is one of the most important things when you're doing the bottom-up approach. You have to test the cables, you have to test the connectors, we have to test pretty much everything associated to the hardware level, including the CPU utilization, error messages, performance related issues, and so on. When we're troubleshooting the data link layer, we're basically troubleshooting the MAC, the physical addresses information, the encapsulation if we have VLANs, the VLAN association on every single one of the ports, and so on. When we're troubleshooting the data link layer as well, we need to remember STP or spanning tree. Sometimes when we have issues with spanning tree, we will have the loops, undesired loops. If we don't configure spanning tree properly, we have the risk of having loops in our network topology. So we need to understand how spanning tree protocol works in order to troubleshoot data link layer. Network layer troubleshooting. When we're troubleshooting the network layer, we need to be aware of the logical addresses. We need to be aware of the IP addresses. We need to know how to find out if two devices in the same local area network, if they have the same IP network. So we have to do those calculations that you guys learn how to do with the subnet mask to find the network address of one device and then to find the network address of the other device. And then we're going to be able to say if they are in the same network. If they are not in the same network, we need to troubleshoot the router, because if two devices are not in the same network, they need to be at least in the routing table as an entry, because otherwise the router will not know how to forward the packets. After we troubleshoot the physical data link and network layer, we can troubleshoot the transport layer. When we're troubleshooting the transport layer, we are basically troubleshooting ACLs. So remember the ACLs that can block traffic from one specific source to a specific destination? Some of the ACLs, they actually have the transport protocol information contained in the ACL filtering. So they will basically filter packets based on TCP, UDP, or the protocol number, port 80, port 443, whatever the port is associated to a packet. We need to troubleshoot the ACLs when we're troubleshooting the transport layer. When troubleshooting the transport layer as well, we also need to troubleshoot the protocols associated to the transport layer. We need to troubleshoot DHCP to check if DHCP is working, DNS, SNMP, tunneling if we have tunneling, and the encryption if we have VPN tunnels, and so on. Now, when we're troubleshooting the application layer, we're basically troubleshooting the applications themselves, and we're basically troubleshooting presentation and session layers as well. So we're basically trying to find out if the issue is actually in the application layer itself instead of the network. Now, in order for us to find out if the problem is with the application itself, one of the easiest ways is to make sure all the other layers are working. For example, if we do a ping and we know that the ping is successful, we know that there's full connectivity in a simple ping, we can then find out if the problem is with the application itself. All right, what are the components of end-to-end troubleshooting? Whenever we're troubleshooting networks, guys, the first thing is to find out if we're doing a ping test, for example, we need to find out if we're pinging a machine in the same network. Because if we're pinging a machine in the same network, we know that the problem is not going to be with the default gateway. If we are pinging a machine in the same local area network, in the same network, we don't even need to have a default gateway information. So we need to define if the machine that we are testing, if it's a local machine or if it's a remote machine. If it's a local machine, it's connected to the same IP network. If it's a remote machine, it's connected to a different network. We need to troubleshoot the router. We need to make sure the network, the destination network, is in the routing table, or if we even have a default route in the router, which is the gateway of last resort, if the entry is not in the routing table. Now, these are the steps that I would take if I was troubleshooting this network. I would check the physical connections at the endpoint. So whenever I have access to the physical connections, I would make sure I would test them first. After that, I would check for duplex mismatches whenever I have access. So if I have access to a computer connection to a switch, I would make sure they have the same duplex mode. I would then proceed to check the data link and network layer addressing on the local network. In other words, I would just make sure ARP is working and I can resolve the MAC address to IP address information. After that, I can then verify that the default gateway is correct if I'm troubleshooting connectivity to a remote device. After that, we can ensure devices are determining the correct path from the source to the destination. Because remember that sometimes with the routing protocols, we can actually have a loop, and we need to make sure we are actually taking the best path from source to destination. Also remember, guys, we have many dynamic routing protocols. Some of them, they will find best paths based on the hops. Some of them will find the best path based on the bandwidth. So when we're troubleshooting, we need to find out that the path that we're actually taking to the destination is the best path, and it's a valid path. We can then verify the transport layer using many different protocols. Telnet can be used, for example, to test that. Then we can verify the ACLs. If there's an ACL blocking the traffic, we need to remediate the issue. After that, we can ensure DNS settings are correct, because if the DNS settings are not correct, HTTP, HTTPS, they will basically not work, because we're not going to be able to resolve the domain names to IP addresses. After that, we can then proceed to execute the tests using the ping and the trace route. Now, when we verify the physical layer, we can execute the command show process CPU on the router or switch to verify if it's being overloaded. We can show the memory as well to see if the memory is not enough. We can also show the interfaces information as well to verify if there are any packets being dropped. We can also check the duplex mismatches with the show interface and then specifying the interface. If there is a duplex mismatch, there's going to be issues in the connectivity as well. Now, we can also verify layer 2 and layer 3 addressing. Now, layer 2 and layer 3 addressing mapping is related to the ARP table. All right. Now, do not get confused, guys. The ARP table has nothing to do with the MAC table. Remember that the MAC table is actually on the switch, and the MAC table is MAC address to interface. And that's how the switch makes decisions. MAC address table and ARP table, they have nothing to do with each other. The ARP table, on contrast, is in the... Does anyone know where the ARP table is located?
Router.
Any other guesses? Sweet. Any other guesses? So we have router, switch,
Okay, host devices. I think.
host device, everywhere. Every device that needs to send a packet, that needs to ping another device, they need to build a frame. And because they need to build a frame, they need to have the MAC information. So ARP is in every device that is connected to the network, on every device that need to ping another device, or that needs to communicate with another device. We will have the ARP table. All right. Now, in our Windows machine, we can check the ARP with the command ARP-A. We can also use the ARP-D and so on. Okay. We can also verify the routing table on a router to make sure we have a destination network. And how do we get there? If we have a destination network in the routing table and we have a way to reach the destination, it's a good thing. If we don't have a network that we want to reach in the routing table and we don't have a way to get there, we have no idea how the packet should be forwarded, and that's where the issue is going to be. After that, we can verify the correct path. We can also verify the routing table to make sure the packet is going to the correct interface. And then we can verify the transport layer using Telnet or SSH. And then we can verify the access lists with the command show IP access lists. It will basically display all the access lists associated to the device, if it's outgoing or inbound access list, and the number of the access list, as well as the restrictions in the access list, the entries in the access list. We can then verify the DNS information. We can try to ping, and we can try to resolve the names as well. There is one more packet trace activity for you guys to do. Lots of fun with many different protocols, with many different devices that you have to troubleshoot. One more as well. And one more as well, because it's never enough. All right, guys, this is everything we studied today. So we basically studied how to explain troubleshooting processes and how we can choose one of the troubleshooting approaches for various network problems. And we also discussed about troubleshooting end-to-end connectivity in a small to medium-sized business network using a systematic approach. There's one more activity for you guys to do as well. And that's all.
Thank you all.